Let's continue. Let's record again. Probably there's a limit. Okay, the fastest lift in the world is the Taipei 101. It's so fast that it has to have the lift capsule has to be aerodynamically shaped. The lift, it actually has this dome. So you stand in it, and then the lift is so fast that they need to get this shape over here so that it reduces air resistance. Yeah, it's one of the fastest lift in the world. They're so proud of it that they even actually show you like how many meters per second rising when you're inside the lift. It's quite interesting. And the Taipei 101, if you're not aware, they have this big damper at the center of the building, at the 88th floor, I think. And because Taiwan earthquake zone, in fact, when they were building the Taipei 101, there was an earthquake, and it survived. So there's this huge damper. It is so famous that it became a tourist attraction. They actually open up for people to look at the damper. It's a huge, huge damper made of steel plates, a few hundred tons, I think. Yeah. And why do they put it here? Why not put it at the bottom? Why not put it at the top? Oh, idiot, sorry. Because lucky? Idiot. Why somewhere between the top, somewhere near the top? Why? Think about this, think about this. Because if they can actually put it at the bottom, they'll put it at the bottom. Why transport it all the way to the top or near the top? Think about this, Ken. Think about this. There's some engineering considerations that goes into it. Think about this, yeah? Some of you might be doing EE on damping. Many students have done it before. Yeah. Okay, let's come back to this. Are you okay with this? Surviving, okay? Now, let's talk about something else. How much time do we have? 20 minutes more. Okay. Now, for some reason, if I were to, now I'm departing from F equals to ma. Remember, there are three parts to the lesson today. One was F equals to ma. The second one was F equals to dp dt. I'm going to move on to this one now. Okay, I got a ball that moves towards the right at 4 meters per second and it bounces off the wall at 3 meters per second. Find the average force if the collision lasts for 200 milliseconds. What I'd like you to do is to find the change in momentum, part 2, then find the average force. And comment why it is called an average force. And then I'd like to extend further using this concept why objects or airbags work. So this is an extension question beyond this line. Why doesn't it record? Why does it stop automatically? Is it still recording? Yeah, it does. So the change in momentum is 8, right? 8, Correct or not? 8, And the answer for the force is 8 divided by 0.2, so it's 40. Correct or not? Correct, It's wrong. It's wrong. Chicka booms. I was waiting for someone to say no. It's the correct answer for the average force is 280, I think. Yeah, 280. Don't laugh at people, lalo. It's like, ha, 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 ha. Actually, I also didn't have it. Come on. Okay, the reason is because if you get 8 is because you treated momentum as a scalar. You just took 8 times 4 minus 3. But you must remember it's a vector. If I take positive this way, this is minus 3. Therefore, change in momentum is always final minus initial, which is minus 24 minus 32, which will give you minus 56 kg meter per second. So force is, and it is equals to minus 56 times 5, which is minus 230 newtons. Now, we don't like the negative sign, so we just throw it away, right? Because the negative sign means nothing, just trouble. So we just throw it away. Right or not? Right? We don't like negative, just throw. No, you shouldn't throw it away because the negative sign does mean something. Okay, yes, sorry. I didn't finish my writing. The other side, yeah. Yeah, 280. I said 280 just now, right? Then I'm going to put 230. So, what does the negative sign mean in this expression? Yes, correct. Correct. Exactly. It means that the force is in this direction. Does it make sense? It makes sense, huh? Because the force on the ball. Now, if the question were to ask you what's the force on the wall, if you stop here, you get 1 mark lesser. Because this force that you found over here, is it the force on the ball or force on the wall? It's like, what? What? Isn't it the same? Same. Now, this force that you found, is it a force on the wall or force on the ball? Now, then you go back one step. How do you find this? You use change in momentum of the ball, right? So therefore, the force that you found over here is the force on the... You go one step further, this is change in momentum of the ball. So the force that you found here is the force on the ball. Yes, correct. Because you use the change in momentum of the ball. Now, if you're asked to find the force on the wall, you need to mention one more line. By Newton's which law? Yeah, correct. Force on wall is also equals to 280. Okay. Must be careful, otherwise you lose 1 mark. Not because you don't know, but just that you forgot. Must remember this. Now then the question is, if the question asks you to find the force on the ball, then you go extra write this. Will it be marked down? You know what's the... If the question asks you for force on the ball, then you go extra write this. Okay, in IB, we don't mark you down. We mark whatever you give us, we mark till here. So what's the rationale? Just ham dam lah. Just whack throw all the balls Every question you just write all the physics equations Yeah. Let's see whether you got time to finish or not. Yeah. It's really true, I've marked IB paper where you don't know whether it's in the English language or whatever language they're writing. Fragments of equation everywhere. Then the person, step 1 do over here, step 2 right over here, step 3 right over here, step 4 right over here. Under IB regulations as marker, we have to find those things for you. We have to, okay, this is step 1, this is step 2. But you just make us very unhappy. You just make us very unhappy. But too bad, we just have to mark it. Yep. But please help us, have a conscience. Otherwise, it's really difficult marking. Okay, next one. This one is going to be more difficult. Let's check. How do you think I'm going to make this question more difficult? How do you mean? 4 meters per second, 4 meters per second, 8 kg, 8 kg. And then collision, this one is takes same thing, 200 milliseconds. How? How am I going to find the change in momentum? 怎么办? In most IB questions, no worries, it will be a symmetrical situation where we'll give you the angle as this. Say for example, when I have a scenario that looks like this, right, what can you conclude about the surface over here? When I have this equals to this, what can you conclude about the surface? Smooth or rough? Smooth or rough? Wait a minute. Smooth or rough? There's no same lah. Smooth or rough? There's no same. Smooth or rough? Okay. Smooth or rough? If it is rough, then there will be a frictional force, right? Do you agree that this component of momentum will slow down? Yeah? Do you agree that if the momentum over here will slow down, it will never be exactly the same anymore? So how will it look like? If there is frictional force, how will it look like? Is it going to be A or is it going to be B? Where this is alpha and alpha, this track C over here is this one, where the two angles are the same. So if there's frictional force, is it going to be B or is it going to be A? How many of you think that is A? If there is friction, how many of you think that is A? If there's friction, if this surface has friction, a ball comes in, is it going to go like this or is it going to go like this? If the dotted line is the path where the angles are the same like this one. How many of you think that for a rough surface it's going to be A? Okay. How many of you think that for a rough surface it's going to be B? Okay. Okay. The answer, no. It's also cheapo. It is B. It is B. Why? Because like what I said, if there is frictional force this way, do you agree that the momentum in this direction is going to be smaller? If the momentum here is going to be smaller, and then you still got a sizable momentum over here, this angle is going to go this way. Yeah? So it's going to go B. So by looking at the collision now, you can actually tell whether it's smooth or rough surface. And that's science, people. That's science. Observation, deduction. Based on laws. So can someone tell me in this example over here, what's the change in momentum? 32. Yes, 32, correct. 32. Strictly speaking, it's minus 32 or positive 32, depending on what direction you take to be positive. Okay? And therefore, the average force is going to be 160. Yes, correct. Now, we haven't finished two questions over here that I gave you just now, somewhere over here, I think. The question over here, the two questions that are left behind is, why is that force called average force? Why is it important to call it average force? Because the force is actually not, it's a 7-letter word starting with C. Constant. Actually, go and count. Constant, correct. The force, how do you think the force will vary as the ball hits the wall? Yeah, it's going to look like this. So this is the force. So what happened is the ball goes like this, then this is the point where he's there. Then it comes back down here. Yeah. Okay. So the average force is the one where we assume this one. So it means the average force is lesser than the maximum force. Okay? Cool. Now, therefore, the last question I asked but I didn't answer, why is it that airbags work? What does airbag do that reduces injury? We know that it does this boing, but what's the physics behind the boing? Excellent. So you take a look. F equals to del P del T. With or without airbag, you start from motion, you end off with no motion. Some people end off lying. Okay? So the thing is that your delta P is the same. But what you do with the airbag is you lengthen the time. And that's why when you jump, even when you do this, try not to do it too high. When you jump up, you land with locked knees. You're going to feel the whole force coming up to you. Whereas if you jump and then you do this, you feel a lesser force. Why? Because you're increasing delta T. Yeah? And that's why when people fall from a high place, some people who are trained, they break the fall by rolling. Okay, I'm sure that there are many stars who does that, who do that. Yeah, so yeah. Why Tom Cruise? Yeah, one of the very interesting people who still quote Tom Cruise. Tom Cruise belongs to my era. Yeah, Tom Cruise belongs to my era. But he's still good looking, that fellow. Yeah, he's still good looking. At that kind of age, oh man. It's like reverse aging. Brad Pitt as well. For some people, they just look better and better. With age, right? You look at Leonardo DiCaprio, it's like when he's young, like wine, just get better and better. Okay, parting gift for you is this. Parting gift, Is there a break for you? Okay. No, relax. Take a chill pill, It's like horror movie. Horror movie, The Integral. Relax. No, you're not. Let me parting it, finishing soon. Now, this one, do you agree that it is del P? Huh? So you substitute PF minus PI, so del P. All I need you to know is area under FT graph. That's all. That's all. Yeah? Yeah, but equation or ideas will float. Let's try one simple question so that it stays. Yeah? So F, I got this force over here, 8. This is 4. This force acts on this body of 4 kg mass or 2 kg mass. Can you find for me, if U equals to 0, the change in momentum and hence the final velocity? Okay, simple question, just to concretize things a bit. So, area under the FT graph is equals to the change in momentum. Therefore, I hope you still remember the equation for triangle. It's not 32, please, not 32. If you say 32, I'll be very worried. It's 6 pi r square. Wow, you might want to check your glasses. This circle. So it's 16 or 16. 16. So make a guess, what's the final velocity? The change in momentum is 16, so the final velocity is lucky number 8. Yes, correct. Lucky number 8. Fa. The Chinese love 3, 9, 8. Doesn't like 4 for obvious reason. 4. Yeah. 3 because it's 生嘛，生。9就是9长长久久。6, the Cantonese love 6 because lok. Lok means prosperity in Cantonese. Yeah, lok. Yeah. So 3, 6, 9, 8. Sorry? Go further to Cantonese. Cantonese. I used to be very good in Cantonese, but wow, when I watch the Cantonese serial drama. 多謝，唔該。It's a beautiful language. Even when they scold people, also sounds nice. It's a very beautiful language. Okay, people, that's it for today. You survived. Thank you, class. Okay, let's do that. How come it's like every time? Let's do that again. Coordinate.
Thank you, goodbye, and God bless you.
Thank you, goodbye, and God bless. Why am I teaching you to greet me? Let's do that again. Thank you, class.
Thank you, goodbye, and God bless you.
Thank you.